Hello friends, welcome back to my channel. So today our topic is process state diagram.
अगर आप नए हो चैनल पे तो प्लीज़ चैनल को सब्सक्राइब कीजिए।
In the previous lecture, we learned about process, what is process, what are different attributes of process, and what is process context and PCB. So today we will learn what is process state diagram. We know that process will have various states. There are you can see here different states of processes. So what are these? Firstly, we have new, then we have ready, we have running, and then there is wait or block, then is termination or completion. We have suspend ready, then is suspend wait or suspend block. Then there are different various operations that are performed on this process. What are these operations? Firstly, creation, scheduling, dispatching, execution, termination or killing. Then we have suspension, and then we have resuming. Okay, now we will see what actually this process state diagram is. So here initially we'll start from this new state. Initially the process, whenever the process is created, it will be in the new state. Okay, whenever process is under creation, it is in new state. After this process is created, it will be scheduled onto the ready state. So firstly, whenever the process is being created, it is in new state. After whenever it is created, then it will be scheduled onto the ready state. But there may be different number of these processes in the this ready state already. But now one of the process is selected from the ready state, and it will be dispatched or scheduled onto the running state. So here I will show. So in the ready state, there may be different number of these processes already. So one of these processes will be selected, and it will be dispatched or scheduled onto the running state. Okay. Now in the running state, there will be only one process at any given point of time. So, but in the ready state, there may be multiple number of processes at any given point of time. But in the running state, there is only one process at any point of time. Okay. Now, if the process is running state, now if process needs some input-output operation, if process need to perform some input-output operation, then it will be moved to wait or block state. So we have processes. If we have processes are of two types. Either it will be CPU bound, or it will be IO bound. So what is this CPU bound and what is this IO bound? Now if any process, if it needs more amount of time in the CPU, if any process will require more amount of time in the CPU, then we call this process as CPU bound process. And if our process needs more amount of time, where if it require more amount of time to perform some IO operation, then we called it as IO bound. Okay, so here we were here. Okay, firstly we start from new. Whenever a new process is created, it is in the new state, and after that it will be scheduled into the ready state. In the ready state, there will be multiple number of processes, but one of the processes will be selected from this ready state, and it will be dispatched or scheduled onto the running state. But now in running state, there will be only one process at any given point of time. Now if any process, if it requires some IO operation, if it needs to perform some IO operation, then it will be moved to, so it will request some IO, there is it requires on some IO request, then it will be moved to wait or block state. Wait or block state, and then when after it completes its IO operation, it will be moved to the ready state again. Now, if some process if some process completes its time in running state, then it will be moved to termination it will be moved to the termination state. Now here in the wait or block state, there will be multiple number of processes at any given point of time. What does this mean? That means multiple number of processes can do IO operation at any given point of time. Now, if the running process completes its execution, then it will be moved to the termination state. Okay. So when the process is in ready state, or it is in running state, or it is in wait or block state, it resides in the main memory. Okay. What I am saying is, if any process, if it is in ready state, or if it is in running state, or if it is in wait or block state, it is residing in the main memory. Now, if the resources are not sufficient to manage the processes in the ready state, then some of the processes will be suspended, and that will be moved into the suspend ready. Okay, and then whenever the resources are sufficient, then it will be resumed and it will be brought back into the ready state. Same happens with wait or block state. Whenever the resources are not sufficient, so some of the processes will be suspended, and that will be moved into the suspend wait. And when the resources are sufficient, then we can resume them and we will bring them back to the wait or block state. So when the process is in suspend wait, or when the process is in suspend ready or suspend wait, it is stored in the backing store. What is this backing store? We called it as secondary memory. Okay, so the suspend wait and suspend ready, where we actually put these, we put them in the secondary memory. So we talked about the transition from new to ready, and from ready to running, from running to termination, and from running to wait or block. And we also talked about this from wait or block to suspend wait, and from suspend wait to wait or block, and from ready to suspend ready, and from suspend ready to ready. So, but there is one more. You can see it here. Some processes will be brought back from running state to ready state. So when this thing will happen? So here I have written here as priority and time quantum expire. What does it mean? So here, if we have some process which is undergoing execution in the running state, but its priority may be low. But here comes one more process whose priority is very high. So what we need to do, we will preempt this process from running state to ready state, and we will dispatch the high priority process into the running state. Same happens. There is one when we talk about time quantum expire. We will talk about this time quantum in our future lectures, when we will be studying this round robin algorithm. So in what happens in round robin algorithm, that each process is given some time quantum. For example, if we have 4 or 5 processes, every process is given time quantum, for example 2 nanoseconds. What does it mean? Okay, there are 5 processes. First one process will be scheduled from ready to running state. It will be executed for 2 nanoseconds, and it will be brought back. It will be preempted. So it will be preempted and it will be brought back into the ready queue. And then another process will be executed for 2 nanoseconds. So that's where we use this time quantum. So whenever its time quantum expires, for example, if its time quantum is 2 nanoseconds, if its time quantum expires, then it will be brought back to the ready queue. So this was all about this process state diagram. Now we will see what is degree of multiprogramming. Okay, the number of processes present in the main memory at any point of time. What is degree of multiprogramming? It is the number of processes that are present in the main memory at any point of time. Okay, so we call it as degree of multiprogramming. Now, each and every time when the process is moving from one state to another state, the context of process will change. What does this mean? Okay, for example, we have one process that is in ready state. Now it will be moved to another state, that is running state. Now its context will change. What does this mean? Context will change. We have already talked about this, what is context, in the previous lecture. So if you want to learn more about what is context, so I am providing link for the previous lecture. You can go there. Okay, so now we have context switching here. Context switching. What is now context switching? It is saving the context of one process and loading the context of other process. Okay, what is context processing? We have to save the context of one process. What is the context? It's actually the attributes of the process. Okay, and then we have to save these attributes of one attributes of context of one process, and then load the load the context of other process. What we called it as context switching. Actually, we are switching from the context of one process to context of other process. For example, if P1 is executing, okay, now we want to remove P1 and we want to execute now P2. Okay, first P1 is executing, then P2 will execute, then for example P3 will execute. Okay, now P1 is executing. Now after P1, P2 will execute. So we have to save the context of P1, and here context switching will take place. Context switching will take place, and we have to load the context of which process? P2. And again here between P1 and P3, here again context switching will take place. We have to load the context of P3 process, and we have to save the context of P2 process. So this is called context switching. So who actually does this context switching? We have dispatcher who actually do this context switching. We will talk about that later. Now, if we have more context, if a process has more context, then it will take more time for context switching. If, for example, if we have more context, if a process has more context, so it will take more context switching time, which is undesirable for any system. Okay. Now, this context switching time, it is an overhead for system, because whenever we talk about system, we talk about speed. Okay, we will see how fast our system is. But this context switching time, if we have more context, it will take more time. The switch between these processes, it will take more time. So it is an overhead, or we can call it as it is an undesirable. Okay, so this was about context switching. What actually is context switching? We have three processes, that is P1, P2 and P3. Firstly, we will whenever the context switch will happen between P1 and P2, so we will save the context of P1 and load the context of P2, and then we called it as context switching. And then if we want to execute another process, that is P3, so we will save the context of P2 and load the context of P3. We called it as context switching. So context switching with different processes. Okay, but here we have one note, that is, in some special cases, if there is only one process, still it is called as context switching. here we have, in this example, we had 3 different processes. So when we were switching between one process to another, we called it as context switching. Okay, but in some special case, if there is only one process, still it's called as context switching. For example, round robin scheduling with one process. So come to here. Here we have ready state and running state. So in the ready state, if we have only one process, P2, for example, P2, and its burst time is, for example, 10 nanoseconds. Okay, we have only one process, that is P2. Now, if the time quantum is, we have time quantum equal to 3 nanoseconds. Okay, so we will schedule this P2 from ready to running, and it will be executed for 3 nanoseconds. Then it will be preempted because its time quantum will expire. Time quantum will expire, then it will schedule again for 3 nanoseconds and for 3 nanoseconds, and then there will be only 1 nanosecond, and it will be completed, and it will go into the termination state. So this was one of the example. Note, in some special case, if there is only one process, still it's called as context switching. For example, round robin scheduling with one process. Okay, now we will talk about schedulers. So we have 3 different schedulers. So first one is long-term scheduler or job scheduler. Long-term scheduler, we call it as job scheduler. Okay, now what is this long-term scheduler? The long-term scheduler is responsible for creating and bringing the new processes to the system. Okay, now we see who actually creates this process. It is the long-term scheduler. Long-term scheduler, we have long-term scheduler here. What it does, it creates the processes and then brings the processes into the system. So then we have short-term scheduler, or we call it as a CPU scheduler. So what is its responsibility? Short-term scheduler, it is responsible for selecting one of the process in the ready state for scheduling onto running state or CPU. So here we have short-term scheduler. Short-term scheduler, as we already know that there are multiple number of processes in the ready state at any given point of time. So what is the responsibility of this short-term scheduler? What it does, it selects one of the processes in the ready state, and then it dispatches that processes into the running state or into the CPU. Then we have one more scheduler, mid-term scheduler or medium-term scheduler. Okay, what's its responsibility? It is responsible for suspending and resuming processes. Okay, here comes our mid-term scheduler. Mid-term scheduler here and here. Mid-term scheduler, what is its responsibility? So I have already told you that in the wait or block state, if we have less amount, if we don't have the resources to handle all these processes, so some of the processes will be suspended. Now who suspended these processes? It is the mid-term scheduler. It suspended some of the processes and then it will resume. Okay, here also, here we can see if we don't have enough resources, then some of the processes will be suspended. Now who does it? It is the mid-term scheduler who suspends processes and then it resumes them again. So the job done by mid-term scheduler is called as swapping. What this mid-term scheduler, what's its job? Its job is to do swapping. What is actually swapping? It is swapping processes from main memory to secondary memory and vice versa. So what this mid-term scheduler does, it it swaps processes from main memory to secondary memory. As I have already told you that whenever the process is in ready state or wait or block state or running state, these processes are residing in the main memory. But if we have less resources in the main memory, then some of the processes will be suspended. So what who does this job? It is the mid-term scheduler that suspends some of the processes So what actually it is doing? It is swapping. It's doing swapping from main memory. So whenever it needs to suspend, it swaps from main memory to secondary memory, and when it needs to resume some of the process, then it will again swap from secondary memory to main memory. So this was our midterm scheduler. So actually you can get in the examination, they will ask about medium term scheduler, or they will ask about CPU scheduler. That's why I have written both these names. Okay, so these points, these are very important, so that's why I wrote them here. Now we have dispatcher. Actually, what is this dispatcher? It is responsible for performing context switching. The responsibility of this dispatcher is to perform context switching, and we already saw what is this context switching. Okay, it is also responsible for loading the selected job on CPU. Okay, now what happens here is the short-term scheduler, it selects one of the jobs, it selects one of the processes in the ready state. Now here comes the dispatcher. Okay, short-term scheduler will select one of the process in the ready state. Now comes the dispatcher. The short-term scheduler selects the process, and dispatcher, it then dispatches the process into the running state. So this is what the dispatcher does. Okay, now the long-term scheduler, so in order to get the good throughput, what this long-term scheduler should do, the long-term scheduler should select the good combination of CPU bound processes and IO bound processes to get the good throughput. Okay, we already talked about these processes and its types. Like some processes are CPU bound, that means they need more amount of time in the CPU, and some are IO bound, that means they need more time in wait or block state or here. So now when we will get a good amount of throughput, that is if this long-term scheduler, it should select the good combination of both CPU bound and IO bound. Now if it selects only CPU bound these processes, then our IO bound, it will be idle. Okay, now if it selects only these IO bound processes, so every process that will come here, and that will be performing IO operation here, and our this CPU, it will be idle. So in both the cases, our throughput will not be it will not give a good throughput. So the long-term scheduler, what it should does, it should select a good combination of CPU bound and IO bound processes to get the good throughput. Okay, now this long-term scheduler, it also controls the degree of multiprogramming. How it controls degree of multiprogramming? Because it is the long-term scheduler who is responsible for creating and bringing new processes. If it creates more processes, then degree of multiprogramming will be more. If it creates less number of processes, then degree of multiprogramming will be less. Okay, so this was all about this process state diagram, context switching and schedulers. Hope you understand. Now if you like this lecture, then please like, share and subscribe our channel. See you in the next lecture. Allah.